This is the beginning of Chapter 9. Chapter 9 has to do with equations and systems and matrices and all that good stuff. So we're going to just start in general with the system of equations. There's different methods that we can use to solve a system. A system consists of more than one variable and more than one equation. So we're going to start easy with 2 equations and 2 variables, and then we'll work our way up. So there's a substitution method where you actually substitute in for one of the other variables. So if we use the substitution method here, we're going to solve this first equation for y, and then substitute this in for the second y. Then distribute. Solve for x. X is 2. Take 2, plug it back in, and we get that y is negative 8. So our point is 2, negative 8. Systems can have 0, 1, more than one, or infinitely many solutions. To have a no solution, then you get 2 things that don't equal each other. If you get this where one side equals the other side, that means that there are infinitely many solutions. So using the substitution method again, we will take this second equation and solve it for y. Plus 3x. Then I'm going to take this, plug it in for the first y, and solve. So remember that that is actually foiling out. It's not just squaring the 25 and squaring the 3. X. Well, each side is 625. Those can just go away then. And we're left with 10x squared plus 150x equals 0. Factor out a 10x. So we have 2 answers. One where x is 0, and the other where x is negative 15, which means there's also 2 y's. So if I plug 0 into the y equation, 25 plus 3 times 0 is 25. Right? Yes. So that's 1 point. And if I plug negative 15 in here, 25 plus 3 times negative 15, 25 and negative 45, we get negative 20. So our second point, negative 15, negative 20. The other method to use is the elimination method, which might be easier depending on how the equation is actually set up. Elimination method means that you're actually eliminating one of the variables completely. So if you look at this example, there is 4y on top and a negative 4y on the bottom. We add the 2 equations. We can eliminate our 4y's, which we get 6x equals 36. X is 6. Now that I have x, I can plug back in. Five times 6 is 30. If you move 34, you get 24 over there. And y is also 6. So our solution is 6, 6. The next example, we have x squareds and a y. So they are all different coefficients. So I'll just choose to get rid of y's. But to do so, I need to make their coefficients the same value, just one positive, one negative. I'm going to multiply the top one by a negative 4 and the second one by a 3. So I get 2 new equations. Oh, I'm doing x squared, it's not y's. Just kidding. I was just kidding. So my x squareds go away, leaving negative 11y equals 66. Y is negative 6. So if I plug back in, I get 3 times -6 is -18. If you move that over, you get 36. So x squared equals 9. X is positive and -3. So there's really two answers. 3, -6, and -3, -6. There's also a graphical method where you can graph each of the equations. Here it is. You can graph each of the equations. So I'm going to graph in y1, I'm going to put x cubed minus x. In y2, I have to move that x squared over and then square root it. 2 minus x squared, but remember when you square root something, you also get the positive and negative version of it. So in y3, it's a negative square root 2 minus x squared. So I'm going to put those 3 in. Oops, wrong button. X to the third, oops, minus x, and then the square root of 2 minus x squared, and the negative square root 2 minus x squared. Probably want to zoom in a little bit. Those really do go all the way, like to the axes, just so you know. So there's 2 points of intersection. One there, one there. So you're going to go to second calc, intersect, move your graph over. So one point is 1.2 and 0.7. And then we have to do the intersection of the other one. Oh, this is going to la la la. Move that Spider-Man over. All the way over. Almost there. Oh. Oh boy. Let's try that again. Okay. I'm on the wrong graph there. I have to arrow down. Now I'm on the second curve. Negative 1.2 and negative 0.7. All right. And depending on how they're set up is really going to say whether or not which method you would like to choose. I probably don't want to use elimination on this one because there's an x squared and a regular x. But I can use substitution. So if I take this, solve for y, I get y equals x squared minus 1. I can plug it in. Well, actually, if you use elimination, you get the same thing. -3. So I'm going to rearrange that so that it looks better. And this can double bubble. So x is 4 and -1. So if I plug 4 in, 4 squared minus 1 is 15. So 4, 15 is 1 point. And if I plug -1 in, -1 squared minus 1 is 0. And then if we're retaining bricks for a garden that are usually 6 or 12 inches long, a 6-inch brick costs 80 cents, 12-inch costs $1.20. We have an 8-foot perimeter, and we're going to spend $10.80. Well, one equation is going to be money. So 80 cents for this will be x, this will be y, plus $1.20 is going to give us $10.80. If we have an 8-foot perimeter, 8 feet is 96 inches. So each 6-inch brick plus each 12-inch brick should be 96 inches. I'm going to use the method of elimination. I'm actually going to multiply the top equation by a negative 7.5. So I end up getting 6 here. And I can eliminate my x's. Then we get 3y is 15, y is 3. So we're using 3 12-inch bricks. If you take your 3, oh, that's not 3, that's 5. You take your 5 and you plug it back in. That's 60. 96 minus 60 is 36. 36 divided by 6 is 6. So we're using 6 6-inch bricks. And that is the end of this section.